B, C. Oh, great. Okay, so you got it right. How did you do it? Very easy. You go to the equation, right? And you want to know what happens to volume, so you solve for volume. Volume is going to be equal to rate constant times the number of moles times the temperature divided by the pressure. So, if it doesn't say anything about, this is a constant, if it doesn't say anything about this, that considered to be also not changing, right? So you consider this point as a constant. So if you double both, then it stays the same, right? Well, that's not an answer of a college student. And this is what our educational system everywhere that we use the multiple choice fails. Because the student who solves this problem, he knows to do arithmetics of high school, elementary school. That's what it is. It's elementary school arithmetic. This is not an answer of a college student. And it is to be an answer of a college student level should be explained as we'll do it right away. And it will take us a few minutes to explain it. Then you truly understand the behavior of gases and the laws of gases. And we should have a system that discuss and sees if you really understand it. But you see, if we do it that way, then we're going to have probably not 15 TAs, teaching assistants. We'll probably have 500 of them. So you see where the problem is. The problem is because what is the problem? We want to do education without giving our heart to it. Okay? All of us, parents, teachers, students, we want to do it without giving our heart to it. And we do it miserably. So let's see at the college level, how would you do this, okay? And then you will say, yes, now I truly understand how we should understand the problem instead of thinking that we are college level students, but really we are elementary school students. That's the reality, that's the truth. Problems can be solved just like a high school student who don't understand anything, and it can be solved in a beautiful way by demonstrating understanding of the concepts, in this case about the laws of gases. So here is a beautiful way you can solve this problem. Convincing yourself that you truly understand. Okay, so here is the ideal gas equation that you will base your work. You start with save some time writing. But you can write it down. I recommend you to write it down. It's going to be pretty good stuff for you. This is an example of solving problems, not believing yourself that you're doing it the right way. This is the way you should every problem when you go and take classes, whatever class you take in science. So we start with a gas. The way we talk and we express these things is very important. So be attentive to what we say. So we have a gas. We have a gas in a cylinder and a piston, as you see here. This is the best way to understand the behavior of gases. If you don't consider this device but balloons, then you are in a big mess. You will be confused. Okay? So you have to consider this device to really make sure you understand gases, because when you come to B and take thermodynamics, you will deal with gases, and if you don't understand them, like today here, this problem, then you will have a big problem in thermodynamics too. You see what happens? One is like a parameter, like in math. So we have a gas. Certain number of moles or mass. If you double the mass, you double the number of moles. You double the number of particles, correct? The number of moles is proportional to the number of particles and proportional to the mass, yes? You double the number of moles, that means you double the mass, you double the number of particles. Remember that, because it has to do with your exam. So we have a certain number of moles or particles or mass, a certain temperature, initial, I, and these can move freely. And if the pressure, the external pressure, let's say it's Px, then this gas is going to shrink or expand in such a way that its pressure is going to become equal to Px. And at that point it will equilibrate, stay there, and that will be the volume of the gas that will have under these conditions, which means this temperature, this number of particles, and this pressure. Because when it stays there and doesn't move up and down, the pressure of gas, it will be equal to the external pressure. Everybody got it? Certain temperature, certain number of particles, whatever mass is, it will have a pressure. A pressure. If it's going to be bigger than this, it will go up. If it's smaller than this, it will go down. By doing so, the pressure inside will become eventually equal to the external pressure, and it will stay there. That volume will correspond to this pressure, this number of moles, and this temperature. Everybody got it? Yes?
So you're saying if you double the particles in mass, it means that you're doubling the particles in the mole?
No, we didn't say anything. We just established what these things mean. Okay?
Yeah.
We didn't go any change yet. We didn't change anything. Okay? So we just established what we have. The problem is telling you, I have this. This is what you have. Correct? Now we're going to see what happens to what? The problem says to see what happens to what? To the volume if you double the temperature and the pressure. Correct? We're going to do it in 2 steps. Otherwise, you will be confused. It has to be 2 steps. You cannot do it at once both. So the first thing we're going to do is we're going to change the temperature and see what will happen. So we're going to double the temperature, so that means the temperature now will become 2 times the initial. Do you agree with that? And we know the law of gas, that the volume is proportional to absolute temperature of the gas, correct? Which means if I double the temperature, we'll double the volume. So therefore, you will have this picture. Now, you will have the same number of moles, double temperature, double volume. Can you see this line here? Can you see that line? It was there. Double volume, and the pressure again is going to be the same. This is the way you accomplish to have the same pressure. Can you see how you can have the same pressure? By being able to move whatever freely. So we used one law. What did we find out? The volume became double. Now, what's the next step? We increase what? We double what? The pressure. So now we're going to double the pressure. The pressure, whatever it is on the top, Px, is going to become 2Px. And because it's moving freely, whatever other changes will take place, that pressure is going to be, the pressure of the gas will be twice as much. Yes? And the volume, we know it's reversible proportional to the pressure. So when you do this double, what will happen to the volume? It will become 1/2. And so you will have this picture. And again, this will be double pressure. The pressure of the gas is 2 times as the initial external, which was the pressure of the gas initially. And these things now going this is the college level of solving this problem and understanding this problem. The other solution is, how do you call that kind of solution? Elementary school. It's like I tell you, A is equal to B times C divided by D. If I double C and I double this, what will happen to A? Who doesn't know that of elementary school? Who doesn't know that? That's what it is. That's not math. That's not chemistry. And if we teach it that way to you, when you go to international competitions, then the United States is on the bottom. That's what's happening. And if any one of us, the teachers, want to see what's happening, we'll have to look in the mirror and see what we're doing wrong and change it. This is the way we're supposed to teach you, which takes time. We don't need these big books. We need 1/10 of them to learn to think, and then we can understand everything else we read by ourselves. Instead of just touching the surface and basically know nothing, just becoming parrots. This is a perfect example to illustrate why science in the United States is failing today. After the 8th grade, up to the 8th grade, average. International competition, average. After the 8th grade, the children of this country believe the modern dream that grades, money, fame will make it. Believe this lie modern dream, and then the international competitions in this country, they go all the way to the bottom. Because we try to teach it the way we said, the way we solved the problem before. Which is, what kind of level? Elementary level. This is the way that we should do it in college. And if we don't do it, we fail you. And we should teach each other, if anybody does it right, the other ones should really do it the same way. So try to learn this way. No matter what the books do, try to get to do this way, because this is the way you will be successful, like Greg. Greg is no different than you. If Greg can do it, you can do it too. If Greg is very happy now, and he will be very successful, you can be very happy and successful too. Because you are no different. You are made from the same wind and the same clay. No any difference. Doesn't have nothing to do with your family and your background. No. It has to do with who you are, truly are. And you are all of the same source. So let's go to the next one. Number 6. It's again something to remember. Really, this isn't a problem about. This is not a problem about understanding something really deeply, right? Just to remember this. So what's the answer? Loud. What's the answer? A. Let's see. A. B. C. D. E. Okay. So most of you got it, right? You just have to know it. From what we said in the lecture, there's nothing really to explain there, right? How about the next one? This one takes the material in the reader, the first 1.5 pages I told you, read it, because continuously we're going to use this concept. You will see now, until we finish this lecture, about how many lectures we have more? About 10, 7. We'll use every day the concept. What? How force, distance, and potential energy relate to each other. These three things, potential energy, distance, and force, how they relate to each other, you will see it all the time in chemistry classes that you will take. 2B, especially 2B, 2C, everywhere. If you have not read it yet, go and do it. You know, if you have done it, then you know the answer just like that. So what's the answer? Let's see. A, B, C, D, E. No good response. Really bad response. Why is that? You have the reader, don't you? You read that thing or you didn't read it? Why you didn't answer this? Have you read the 1.5 page? Before even the material in the reader starts. Your teacher put it on purpose before the book starts talking about chemistry, right? It's there before the chapter 1, whatever starts. Why? Because he considered it so important, that's why he put it there. Which many books start talking about all these different ideas and concepts, and they don't prepare the students to have that 1.5 page, to really understand all these concepts. Why would you not go and read it? Did you think it more? Let's try again. A, B, C, D, E. So most people said B, and that's bravo, that's correct. How many people do not understand why it's happening this way? Let me see your hands. Let me see your hands. What are you going to do about it now? Because it's not just about this problem, it's about many concepts and problems in the future, the next quarters. Okay? Go and read it. Because if you do, I'm pretty sure you will understand it. If you have a hard time to understand it, ask the TAs, ask your teacher. Okay? It's very important relationship between these three concepts to really get it. Okay? 8. Okay, that's something that you just have to remember. There is not really much to talk about it. What's the answer here? Loud. What's the answer? B. Right? And how about 9? That's a good one. It's easy to deceive us. It's pretty, be careful when you answer this, okay? If you've not seen it before. Think about it. Just a few seconds and then we're going to go over it, right? Okay, what's the answer? A, B, C, D, E. What's going on? How many people do not know? Let me see your hand. Come on, why don't you raise your hands? You didn't raise them before. Let me see your hand. How many people can answer this? There's nothing wrong with when you don't know something. Why should you be ashamed if you don't know something? Why? Why? Understand why you feel that way. This is going to help you more than get BS, BA with 4.0. To understand why you feel like threatened, to raise your hand and say, I do not know. By graduating from this college, it will help you more to understand why this is happening, because when you understand why it's happening, then you will become free, which means you will become very smart and wise and fearless and successful. So raise your hand. Don't base who you are on the opinions of other people. What's density? Density is mass divided by volume. So what do? You double the absolute temperature. You have the gas in a container with a fixed volume. Yes? Fixed volume. And you change the temperature. If the volume is fixed, that means it's a state, something that cannot shrink or expand. Fixed volume. What is this? Constant. Yes? What doesn't matter what you do to temperature? Increase, decrease, the volume is fixed. So volume is constant. When you change the temperature, what happens to the mass of the gas? Does it change? Does the mass of the gas of something change by changing the temperature? It's inertia from physics. Matter is a measure of inertia. How much it is. Does it change with the temperature? No. It's a constant. So what's the answer if you double the temperature in a gas with fixed volume? Stays the same. You see? Maybe you did not pay attention when it said fixed volume. Maybe that's why you missed it. Huh? No? Yes? Anyway, did you understand it now? Everybody understood it? Okay. We're done with the first part. Let's do a few problems on the other part. Okay, let's do this problem here. Try to do it. I'll give you 1-2 minutes. Really doesn't take much. If you know how to do it, it will not take you more than 2 minutes. So try it. Are you having fun? Huh? Are you having fun? Or you're depressed about your exams? You gain nothing by being depressed. The only thing you do is you will do worse. So you might just detach. Not from the results only, even from your working towards the results. Detach. You cannot put the whole world in your shoulders and carry it around and say, you know, I'm a problem solver. And all the world is on my shoulders. Try something else. That which is in you. Catch. Pretty good catch. Oh, beautiful. Okay, did you guys do it? Did you do it? Pretty good catch. What's the answer? Anybody get the answer? Huh? Okay, well, this problem is based on the equation of energy of a monoelectronic species, correct? You remember we had an equation that gives us the energy of an electron of a chemical species that has a nucleus. We don't care about the charge of the nucleus, but has only one electron. In that case, if there is only one electron in the vicinity of the nucleus, then the energy of that electron is equal to minus RH constant, Z square, the square of the atomic number of the nucleus of that chemical species, divided by the square of the first quantum number, which tells us in what orbit, Bohr's theory model, yes? What orbit, 1, 2, 3, and so on and so forth. So that's the equation we're going to use. All right. Now, we need to find both, because we're going to compare them, right? If you want to compare them, you have to find both. So, lithium, right? Lithium, 2 plus, you can see it has 3 protons and 3 electrons, if it's neutral. If it's 2 plus, there's only electron. So I can apply the equation of this with lithium 2 plus because it's a monoelectronic species. Do you agree with that? Okay. So in that case, the energy in the first orbit, n is equal to 1, so I put 1 here, it will be equal to minus RH, because it's lithium is going to be atomic number 3 from the periodic table, so it's going to be 3 squared divided by 1 squared, so eventually it's going to be minus 9 RH, and because the answer you can see has joules, I have to do some work. So you go on the last page of the exam, you find out the value of RH in joules, and you put the numbers there. You will find out that it's minus 1.96 times 10 to minus 17 joules. But you can see most of them, 3 of them are like that, so immediately you know that the answer cannot be this and that, because you have minus here and this is plus, so one of these 3 should be, 1, 2, 3, one of these 3 should be. Okay? Now, how many times? How many times, relatively speaking, the 2 energies? Well, there's no way to do that unless you calculate the energy of the hydrogen. So here is hydrogen, an atom of hydrogen, and you talk about, again, the electron in the first orbit, and that will be minus RH times, in this case, we have what? Z is equal to 1, because it's hydrogen. 1 atomic number, yes? So it's going to be 1 squared divided by n is equal to 1, so it's going to be 1 squared. And that will make it minus RH. Now, I want to compare them. It will be silly for me to try to do the same calculation we found out in joules. I want to compare them. I don't need to go into joules, blah, blah, here. Who cares? Because I want to compare them. So here I can compare them by comparing these two. Isn't that right? So I can say one of them is 9 times. Good, 9 times, so 9 times, 1, 2, 3, 9 times is equal, this goes away, 9 times, both of them is good so far, one is higher and one is lower. Oops, now we've got a problem. We answered 2 things, but the 3rd one we might get stuck. And if we get stuck there, we might miss the problem. You see, this problem is 3 answers. You get the 2 correct and the 3rd one wrong, you lose it. Okay? And what is the answer? Lower or higher? We're not going to go and explain it, because it has to do again with what? The first and a half page in the reader. Otherwise, you will not get it right. You don't understand the relationship between distance, energy, and potential energy, and to take into account the convention we made, and we said that the energy of an electron, or better, more scientifically speaking, the potential energy of the nucleus and one electron, when they are in infinite distance, by definition, we say the energy takes the value of, not that the energy takes the value of 0, but the energy actually is the, come on, the maximum value. Yes? Nucleus, electron attract each other. You pull it. How are you going to pull it? That means all that energy you put in, now it's in the system. If you let go, it will just, right? Like the string, right? So, as you pull it, by definition, we put the value of the energy of the system, nucleus and electron, by definition, convention, 0. But the energy is not 0, it's what? Maximum. Yes? Same thing as we said about the temperature of water. Because it's 0, 10 degrees Celsius, doesn't mean that the movement of the particles of the water is 0. They don't move at all. They're just still. No. That doesn't mean that. 0 means that the relative average motion of the water molecules is lower than when the water is at 25 degrees Celsius, and it is higher actually. The average motion of the water molecules at 0 degrees Celsius, ice or water, doesn't matter, is actually higher than when it is minus 20 or minus 80 degrees Celsius water. It's an ice. You see, it's a relative. It's all relative. These numbers mean nothing. Numbers in the scale of infinity are very deceiving. It's all relative in that sense, right? So you understand now? Now what is going to be? Let's see. How many hands say lower? Let me see. How many hands say lower? It's lower. The answer is lower. How many? How about higher? Half and a half. And most of people did not answer it. So that means you have to go and read that page again. The answer should be lower. Okay, let's go to the next one. Oh, we should take a break. Oh yeah. We're not going to take a break yet. All right, let's go to the next. Try to do this one again. Let's take 2 minutes. Okay, this is a very problem, should do it fast. Who did it already? We catch the ball now. Somebody can do it right away, just like that, by just looking at the numbers. Right? It's a matter of experience, it's just a matter of practice. Because you don't do it in a few seconds, that means that you have lower type of nature. No. You are exactly the same nature like everybody else. What is it? A mind full of ghosts and fears? No. That's self-imposed. What is it? What are you? Where do you come from? Huh? Where are you going? Where are you going? Where did you come from? Who are you? Why don't you answer this question? Why don't you try to answer it? And then these classes and all these things will become piece of cake. You will do the work in spend 5 hours in 1 hour. Why do you not trust that? You don't believe it? You don't believe it because that's why you don't try. You need to work on these questions, find answers. And then these things become piece of cake. We're going to see 6 minutes as a break. 2 great spirits speaking to you. The spirit of success. If you take it, you will become peaceful, happy, and successful. If you ignore it, look, how many people are sleeping right now? They are on their bed. How are they going to be successful? Yes, Sunday morning, 8 to 10. These people, they come here, they show diligence, persistence, patience, and you will most likely, most of you will be successful. Where are the rest? There are hundreds of people that are not here. These 2 classes have 900 people. This auditorium should be filled up right now. Where are they? Sleeping. Why they're sleeping? Because yesterday night they were abusing their minds and their bodies. That's why. So now, they don't have the willpower to get up from bed and come. No willpower, no physical power either. The body cannot carry through. Just like an engine, there's no oil, it's burned up. Beautiful tires, beautiful car, no gas. The battery is new, nothing happens, there's no gas. It was continued just the day night. Alcohol, impure thoughts, gossip, watching and eating the bad stuff, thinking the bad stuff, today morning they don't have the power to come through. Do what they're supposed to do to succeed. Congratulations to you. Keep doing it that way. So what the answer? A, B, C,